Assalamu alaikum. So in this meeting we will talk about the modular programming. Okay, what does it mean, modular programming? So far in the course you have gained experience with the three main programming structures. So you have already experienced about the sequence, the selection and the repetition. Okay, so in this meeting you will learn, or you will have an idea about the nesting programming structures, the problem solving with custom blocks. Okay, we'll learn how to use the custom blocks, practice using your problem solving skills and applying the programming ideas. Okay, so now you have all the tools about programming, the sequencing, the selection, the repetition, when you can use the selection, when you can use the repetition. Okay, all these skills, you have already these skills, but you need now to use these skills, to practice these skills and to apply these skills in your programming. Okay, so what does it mean, nested structures? Nested structures, it means that you have one structure inside the other. Okay, so look at this example. Activity 5.1 contains the octopus hand program. So start the program with the green flag and follow the instructions to play the game. Okay, the octopus will simply follow your mouse pointer to get away from the shark. Okay, stop the program with the red stop icon. So this is the code or the script of this program. Okay, we will begin. This is my event. Okay, this is the point of the octopus. Okay, and forever it will play continuously. Okay, you will reset the timer, you will wait 1 second and you will keep touching the octopus. Okay, to go from one place to another. Okay, until what? Until the shark catches the octopus. So it will be the game will finish. Okay, so look at the code of this activity, and which has loops within loops. Okay, which has loops within loops. This is the first loop. Okay, forever, and this is the second loop, repeat until. Okay, so here we have, can you identify the inner loop? Where is the inner loop and where is the outer loop? This is the outer loop. Okay, this forever. Okay, inside this outer loop we have the inner loop. This is the inner loop. So this is the inner loop. Yeah, the first is the outer and the second is the inner. Okay, it is inside the first loop. Okay, so can you identify the outer loop? Okay, so the inner loop is the one formed by the repeat until block. This is the inner. Okay, repeat until. It makes the shark chase the octopus, that is repeatedly move toward the octopus, appearing animated until the octopus is cut. Okay, and the outer loop is the one formed by the forever block. It makes the shark chase the octopus repeatedly, and each chase ending with the shark appearing to eat the octopus and displaying the duration of the chase. Okay, so this is the role or the purpose of the outer loop, and this is the purpose of the inner loop. Okay, so this is the inner loop. And this is the outer loop. Okay, okay, so we're reducing the complexity. What do you mean complexity here? What do you know about complexity? What does it mean, the complexity of an algorithm or the complexity of a program? What does it mean? Complexity. Do you have any idea about the complexity? No? So the complexity is about the number of operations in or iterations inside one program, okay? And it is a very important field in every program, okay, because it will show you an idea about the efficiency, about the efficiency of the algorithm. So some complexity in programming is expected. And if you want a program to do an interesting and complex task, it is expected that it will not be short and straightforward, okay? It will be more complicated. It will need more operations, more iterations, okay? It is also possible you will not get the program right straight away. However, there are some techniques that can help you to manage your complexity by structuring your programs into parts, so they are simpler to create and to understand afterwards, okay? So this is for the complex, for the very complicated programs. You need to divide this program into parts, okay? Small parts, okay? To get your program easier to manage, easier to understand, easier to implement, okay? So the basis for this is the make a block facility for creating custom blocks. We can create custom blocks, okay? What is the aim of this custom block? It is what? It is to make your program easier, to make your program divided into parts, into, you can see the here. Do you see? No? You cannot see my screen? You see or not? Yes, okay. Okay, so what does it mean, make a block? Make a block facility in OU build allows you to create custom blocks, to create simple blocks, okay? So creating a block to implement a task needed in several scripts so that the single block can be used in those scripts rather than duplicating code, okay? When you have some parts that are the same in different part of the program, so you can create one custom block, and after that you can use this custom block several times, okay? So look here, for example, in this exercise we have some custom blocks. Look at this custom block, it is called wake up. Here, go to sleep, okay? And look here in the whole program. In the first, the oil will wake up. It will ask you what bird are you spot, for example, and get your answer and join your answer to the to this variable, okay? And once you finish, it will go to sleep, okay? And when you need to call or to wake up this, for example, oil, okay? So you can use another time the custom block wake up, okay? And we'll ask you another thing, for example, okay? So this is one example of go to sleep. Okay, look here. Instead of having to duplicate the code for waking up, okay, instead to write here this code, write here this code, and after that I need this code another time, so I will write again here the switch costume, the change color, the play sound, okay? Now I will of wake up in each one script. The code for each was created just once, only once, okay? So then, whenever needed, the block is called, okay, with its name resulting in its code to run, okay? So using custom blocks to implement duplicated tasks has many advantages. What are the advantages of using custom blocks? So it will save time, save effort and space. It will reduce the risk of error, okay, because you don't need to rewrite your program again and again, just once. Just be careful about the first one, okay, and after that you can use this code several times, okay. Make the structure of the code simpler and hence easier to understand, so it will be more readable, okay. Look at this nested loop. So we now consider how and why loops may be nested inside each other. So look at this example, activity 5.2 have provided use the blocks stamp and clear from the pen palette. So shown in figure 4. So we have a clear and we have a stamp in the pen palette, okay? So the stamp block stamps a copy of a spirit's costume onto the stage, okay? For example, if you have an oil, it will duplicate. You will have several oils, okay? And the clear will erase, okay? Will clears all such images from this stage. So look for in the figure 5 shows a loop that makes oil stamp a row of 8 oil images, okay? Each colored slightly different. Okay, so look here, I will repeat 8 times. I will stamp the same oil, change its position, okay, and change its color, okay, and I will repeat. So I will have 8 oils with different positions and different colors, okay. It does this by repeatedly 8 times stamping a copy of the oil's costume on the stage, moving the oil 40 steps to the right and changing its color, okay. So this is what we will have, okay. Suppose that we want to produce 2 rows now of oil. So this is the first code, okay, this one. When we repeat with the 8 times, we will change X and we will change the color, we will get this line, okay. Okay, once we need to make another row, so we need to go through the first position, okay, and do the same thing, do the same block, okay. So so one way to do this would be to use the row producing loop, so that the oil makes the first row, then move the oil down and left, and then make a second row by repeating the same row producing loop. Okay, by the same code, we can have another line or another row. Okay, so this is, look here, this is the first position of the oil, and I will repeat 8 times, so it will make the row of the first row of 8 oils. After that, I move down, then left, okay, down, this is down, okay, and left. I will be here, the oil will be here, and I will doing the second row, okay, by the same way. So look here, we have repetition here. This block, okay, is the same as this block. And imagine that I need, for example, 8 rows or 6 rows. So I need to write the same code 8 times or 6 times, okay? So this is why we need here to create custom block. So if we have a custom block, okay, that called, for example, 8, or that called stamping or stamp oils, whatever, okay? So I can use this block here, I can use this block here, I can use this block whenever I want, okay, or wherever I want. So what we want to produce 6 rows of oils as figure 8. Look here. So you could add 6 row producing loops with oil moving down and left between each, but this would produce a very long script. Imagine with this script, okay? So I will move to the same, to the first position. I will create the second row, the third row, the sixth row. So the code will be very long. Why? Because I have several scripts that will be repeated. Okay, the same phrases, the same instructions will be repeated several times. So you can write these scripts in a much simpler code if you recognize that there is a repeated task involved here. It is making a row and moving down and left. So this is a repeated task. We can, this task, because it is repeated several times, so I can create a custom block that will do the same thing, okay? And I will use this block, custom block, whenever I need, okay? So like any repeated task, it can be achieved using a loop, and this script can be amended so that oil repeatedly 6 times makes a row and moves as showing in figure 9, okay? So look here, this is my loop now. So loop, I will repeat 6 times. This is the outer loop. This is the inner loop, okay? And I will create this row several times, okay? This with several positions, okay? So this is when we can use the nested loop, okay? The nested loop will keep your program easier to more readable, easier to implement, easier to understand, okay? Okay, look now at the modular programming. So what does it mean, modular programming? Modular programming or component-based programming. Component-based programming, okay? Component-based is concerned with creating programs organized as relatively small modules, okay? As if you have several modules and you need to join these modules, okay? Which together achieve the overall tasks required of the program. So this is what does it mean, modular programming. Modular programming means that you have that you create programs, okay, by several small modules that together can achieve or can achieve the overall tasks required by the program. So modular programming enables the programmer to focus on a program at varying levels of details in a structured manner, okay? You will focus on this program, okay? You will divide this program, the whole program, in small parts, and you will focus on each part, okay, separately, okay? So this tends to result in code that is easier to create with fewer errors because the programmer can concentrate on implementing one small task at a time in a separate component. And it will be easier to understand because the structure of the code will be clearer, okay? So with these modular and with these small component, you can reuse these component. So professional developers are concerned with the potential for future reuse of their components. This component, you can use this component several times, okay? As well as how components may simplify their current program. Okay, is it clear? Is it clear what does it mean modular programming and how to create components, how to create small modular parts? So we have Sadia present. هاجر, are you here? هاجر, مؤيد, أروى, ميسون, نجيب, رزان, مرح. ما راح. اوكي هي ما راح اشرب. اوكي سلطان، محمد، سلطان، عمر، مفلحي، بدر. أنس، ميريس أنس، زينب، سيف. What is your problem, Saif? Can we go back to what the blocks means? Which block do you mean? Which block? These blocks? بروج، يارا، انهار. مها، بسمة، تركي، ياسين، هي راما، محمد، عواجي، مثال الشهراني. اوكي محمد ناصر، معاذ، ريم، ريناد، ريمة، فيصل. اوكي محمد، we see your name. محمد ناصر. اوكي بخيت العواجي. اوكي don't worry. I will take all. سامة. اوكي بدر. اوكي ريان، ريان، ناسي ريان. I have بدر، محمد سعيد، زكية. اوكي زكية. فيكتوريا، where is فيكتوريا؟ سعد، سعد نايف، سعد الغامدي. اوكي سعد you are here. You have سعود نايف، سعد الغامدي، نواف، نادية. اوكي بدر، محمد سعيد. اوكي انصاف، عطا، هناك. يا سعدية noted. اوكي عويض، بكي، إبراهيم الزماني. Okay, we have هاجر. هاجر here. هاجر. We have مؤيد. We have أروى، ميسون، نجيب، رزان، عويض، عبد العزيز، خالد، حصة، علي. اوكي عويض سلطان. اوكي عبد الله امين، عبد الله امين خماش. yeah. في عبد الله الخليل. اوكي عبد الله الخليل. في خالد، في حصة. خالد سالم. نو. خالد. اوكي. في نادر خالد الحميدي. عبد الرؤوف صالح. بدر محمد سعيد. اوكي. فراس. وليد، حسام، رغد، محمود، ريان. اوكي. ريان هير. جبر، زينب، شهد، معاذ، ريناد. صالح فهد الخريسي. صالح. اوكي. محمد علي. حسن ممدوح. ريناد. اوكي. ريناد الزهراني. Okay, so let's. Okay, so here. Okay, I know. I will take another time your. Okay, don't worry. Okay, Naif. Okay. Victoria. Okay, so this is what does it mean, modular programming? Okay, just we will take another time the attendance. Okay, so don't worry, just focus now, make your attention on the lecture. Okay, so by this modular programming you can reuse. Okay, you can reuse your modular or your modules. Okay, so you can, whenever you have a module that will stamp your oil or will write, okay, several or will create, for example, lists, or will create strings, whatever. Okay, so you can use these blocks. Okay, it is also for refactoring. What does it mean, refactoring? So refactoring a program concerns amending its structure to improve it whilst not changing what it does. Okay, so you can reuse, you can make your program improve. Okay, your program. Okay, Zakia. Okay, take Zakia. It is noted that you are present. It's okay. Okay, so to the user, the program behaves identically, but inside the box, the program code is refactoring. Okay, is done well, is better organized. Okay, more modular and easier to understand. Okay, perhaps okay, it comes that you write your program in very bad structure. Okay, after that, when you review or when you see another time, okay, your program, you see that you have many repetitions or many unused, for example, variables. Okay, whatever. So you can refactor your modular. Okay, it will be more easier, it will be more readable, easier to understand. Okay, and potentially reusable. Okay, so move now to the problem solving in action. So as problems get more complex, we need techniques which enable us to break down solving the problem into smaller parts that can be more easily managed. Okay, when you have a complex program or problem, you need to break down your problem, okay, into smaller parts, into smaller modules that can be easier to manage, okay, and easier to implement. Some processes may be identified which represent important distant tasks each sub-process can be implemented as a component, and by doing this, you will simplify your program, okay? Okay, so the first step is designing components. You need to design your components. You need to divide, to break down your problem, okay? So sub-processes which will be implemented as components can be identified early in designing the algorithm. Sometimes these can be identified later, okay? Some people prefer to give more details to a complex algorithm before thinking in terms of partitioning into some process, okay? Some like to break down the structure, but both personal preferences and the form of the specification influence the design process. And what matters is that you end with an algorithm that is partitioned sensibly into understandable parts, okay? So this is what is important. You need to understand, you need to divide or to break down your problem in readable and understandable parts, okay? After the designing of components, you need to implement these components. So partitioning the processing involved in an algorithm into smaller, more manageable sub-processes makes the algorithm design process simpler. Okay, so when what is involved is more complex, retaining those sub-processes as distant parts of the final algorithm can make the algorithm itself easier to understand and then to implement. Do you remember in the last lab we have the book, okay? We have your friend that asked you to create a program for organization of their books, of her books, okay? So she asked you to ask for the book title. Check if this book title inside the library. Once it is not inside you, it will be added, okay? So we have already divided this program into sub-processes, okay? The first sub-process is for asking and checking if it is the book is, if it is inside your library or not. After that, another block that help you to add this title to your library if it is not found, etc. Okay, so a bottom-up approach, and it means that individual components need to be implemented first, checked and tested, okay, and finally the whole program will be put together. I will put all these programs, all these components, all these modules together to have the whole, to achieve the required task, okay? So in general, it is sensible to implement first any components that do not depend on the results of any other component, then to implement those that only depend on the results of components already implemented, and so on until all components and scripts are created. It is called the bottom-up approach, okay? We have this component. Look at this. We have several components here. I create this component for printing, this component for asking, for example, this component for checking, this component, whatever, okay, the purpose of each one, okay? After that, I need to check what is the component that depend, okay, that do not depend on the others, okay? So I will look into the dependency between these components. So for example, for these components, I need this one, okay? So it will be checked, okay, and tested. And after that, for this component, I need this one, okay? So I need to establish this connection, okay, this testing. And for this component, I need this one, for example, okay? So it will be like that, okay? It is sensible, okay, To implement first any component that do not depend on the results of the other. Okay, if there are some dependencies that one component works with the result of other components, so you need to check that. So then to implement those that only depend on the results of components already implemented. So this is what is called the bottom-up approach, okay? And after that, you need to test and debug the complete program now, okay? So the bottom-up approach applies also to testing complete programs which contain newly created components. If we simply test the overall program and a test fails, it can be hard to locate the source of the problem, okay? Is it in the components or in the way they have been used, okay? So this is the problem. Once you make your components together, and when you test your program, you see that you have errors, okay? So you don't know if there are some errors in the components or errors in the way of relating these components, okay? So what shall you do? So instead, we can start by testing each component in turn again, beginning with those that do not depend on the other components. Okay? So you will need to test the components one by one, and that are not begin by the components that do not depend on the others. Okay, we make sure that each of them works correctly. If not, then we correct the problem. Making sure a component meets its specification is also important for use. And once we have tested and, if necessary, debugged our components, then we can progress to testing the overall program. Okay, so we need to test on the bottom by applying the bottom up approach. Okay, we are not required to test the whole program at once. Okay, step by step. So when testing a completing program that involves already tested components, if a test fails, there are some common errors worth looking for. Okay, so once you have already checked your components is working very well. Okay, but when you try to test the whole program, the test fails. Okay, so you need to check the common errors. The wrong components may have been used, or the right one may have been used but in the wrong order. So you need to check the order of these components. Data upon which a component depends may have been set incorrectly, or incorrect data supplied to the components. Okay, and a component's result may have been used incorrectly. So you need to check all these components, all these inputs and outputs, okay, of the components, okay, and the order of these components. Okay, look at this example. So you have the program specification. In this program specification, you can read that my grandson wanted to know the names of the birds that he saw in my garden during one morning. Okay, so I told him to think about the birds and describe what he saw. He said that the first birds he saw were different colors. Okay, two of them were brown but different size, and one was blue and yellow. Okay, so you have two colors and you have different sizes. Okay, so analysis now and description. You need to analyze this program specification. You need to understand. You need to have these parts, okay, these components. So I explained that the larger of two brown birds was a song thrush, and the smaller brown bird was a sparrow. Okay, so this is two types of the brown, okay? We have brown, we have big and smaller, okay? The blue and yellow bird, which was about the same size as the sparrow, was a blue tat. So later on, another bird appeared that was about the same size as the sparrow, but although it was mostly brown. So it has a red crest, okay? I told him that this was a robin. And another bird was the same size as the song thrush, but black all over. So this was a black bird. Okay, so this is the size, okay, and the colors. Okay, so you see here we have different colors and different size. Okay. So finally, two much larger birds came into the garden and scared the smaller birds away. One of these was mainly black, but has some white on it as well. This is a margipane, okay? The other was gray, blue, and pink, and was a wood pigeon, okay? This is the wood pigeon, and this is the margipane, okay? So I found a bird field guide with pictures of the birds. This is the birds that are described in the program specification. However, my grandson didn't think he would be able to remember them when I wasn't there to show him the guide. Okay, so to help my grandson, I want a program that will ask him for key facts about a bird and suggest which bird he may have seen. Okay, your son don't know these names, but using the description you can know the name of the bird. Okay, so I will assume for simplicity that these are the only birds that came into my garden. Okay, so we have the two colors, okay, the browns and the black and white, and we have the size. Okay, so this is big, we can see that it is the big one, okay, the medium, okay, and the small one. Okay, we can see that. Okay, design an algorithm. Now there are two types of fact. There are type of size, okay, and color. So with the birds described here, knowing whether the bird is small, medium, or large, and knowing the colors of colors enable me to identify the bird. I can write down an initial draft. Okay, so input key facts about the appearance of the bird, decide the name of the bird, and output the name of the bird. Okay, this is one algorithm. This is the first draft that I write. Okay, is it clear? Are you with me? Are you with me? Is it clear? Is it clear? Okay. Okay. Okay, after that, the situation is complex to write down in words, but in these situations, a diagram helps, okay? When you use a diagram, so it will help you. Okay. A selection to decide the bird name can be made in two stages in terms of two questions. So you ask for the size, and you can use ask for the color. Okay, so I draw the diagram in figure 11 to show the two stages, the question, the possible answers, and finally the output. This is a diagrammatic representation of multiple stage selection involved in my algorithm. So look here, I will ask for the size. Okay, if it is small, for the small, I have different colors. Okay, I have brown and red, brown and blue and yellow. Okay, I will ask for the medium. And I have for the medium two colors. I have the brown and I have the black. Okay. And for the large, I will ask for the color, and I will have black and white and gray, blue and pink. Okay. So this is my, okay, so this is the color. This is the size. Okay. This one. Okay. So if it is big, I have two colors. If it is small, I have two other colors, and if it is medium and if it is small, I have three colors. Okay. It's one way of solving this program. Okay. Are you with me? Is it clear? Okay. So look, now I can start to add more details to my computer now, to my algorithm, sorry. So I will input the size, I will input the color. I will use the size and the color to decide my name of bird, and I will output the name of bird. But it is still more very general, okay? So I can refine my algorithm. Look here, I can refine, I can add more details to my algorithm. So I will input the size, small, medium, or large. If it's small, I will input the color and decide the name of bird. If medium, it is the same thing. I will input the color and decide what is the name of the bird. And if it is large, I will decide input the color and decide the name of the bird. Okay. And finally, I will output the name of the bird. Okay. So my algorithm is starting to look quite complicated. So I review it and identify some sub-processes deciding on bird name, giving the bird color. Okay. So there are some three different sub-processes. Okay. This is the three process. Okay. It is the identifying the small bird, the medium bird, or the large bird. Okay. And after that, I can decide on components. So my algorithm sets out some sub-processes. Each represents a reasonably substantial and distant task. Okay, so to simplify my program, I will implement each as three separate components. Okay, one component to identify the small birds, one component to identify the medium bird, and one component to identify the big bird. Okay. And for example, the small bird. For the small bird, this is the first component. I will input the color, and I will decide if it is brown and red, so it is the name. If it is brown, so this is the name. If it is blue, so this is the name. Okay. It is the same thing for this for the medium bird and for the large bird. So we have three components now. And this is the implementation of my program. Okay. So this is the program is shown in this figure. It uses three custom blocks. Okay. Identify small bird, identify medium bird, identify large bird. Okay. And by this modules, so my program will be easier to understand and more readable. Okay. Okay. So I will ask for the size, and if the size is small, so I will identify the small bird. If the size is medium, so I will identify the medium bird, and if it is large, so I will identify the large bird. Okay, so this is one way to solve my problem. Okay, is it clear? So having completed this part, you should be able to describe the task performed by a Now You Build program involving nested selection or repetition or custom blocks. Amend or create a small or you build program involving nested selection and repetition to meet the specification and making appropriate use of custom blocks. Create an algorithm involving nested selection and or repetition to solve a problem, including identifying the sub-processes. Okay. And implement a small or you build program involving nested selection, okay, and repetition including defining custom blocks to implement sub-processes that represent substantial cohesive tasks. Okay, this is my program. Is it clear? Do you have any question? So we will look to the OU build. This is OU build, and this is custom blocks. This is more blocks here, and make a block. Okay, so if you need to, for example, here identify more bird, for example. Okay, so this is my identify small bird, identify, and when we wish to use this small custom block, I can use this one. Okay. Okay, so I can create more than one block, identify, medium, bird, identify, big bird. Okay, I can use options. Okay, I can use options. I can use, for example, a number or string or a boolean. Okay, I can use a label. Okay, so if, for example, your custom block needed some numbers, okay, so you can use it, you can add it. Okay, so here, sorry, can edit here, big bird. Okay, so this is my 3 blocks. I can create these blocks, the several types, okay, the several steps, and after that I can what? Okay, so this is, for example, one. Okay, for example, so events. So I will ask for the size. Okay, what's is the size of your, sorry, your bird? Okay. So I will have, for example, make a variable called size and set size to answer. Okay. Set size. Okay. If now if the size if is equal, okay, I can, is it clear now? Look here. So this is my small, my medium, and my big. Okay, is it clear now? So if the size is equal to 1, okay, so I can use here what is, or if the size is equal to big. Okay, so what is the size of your bird? Enter 1 for small bird, 2 for medium bird, and 3 for big bird. Okay, then use it. Okay, if size is equal, if size here size is equal to 1, what does it mean? 1. Okay, so it will be small. Okay, 1 is no, it is not this one. Identify small bird. Okay, else if the size is greater is equal to 2, else if size, sorry, duplicate here, here. If size is equal to 2, okay, then I will identify the medium. Identify the medium bird, okay? Else it is not 1 and not 2, so it will be 3, okay? So I will identify the bird, okay? Is it clear? For the bird, I need to implement these components now. This is my role now. This is the whole program, and I need now to implement the different components. Okay, so for these different components, for example, for the identify the medium, I will ask you for the colors. Okay, so what is the color? What is the color of your bird? Okay, and I will have here variable called color. Okay, and I will set the color to the answer. Color to the answer. Okay, for the medium, what are the colors for the medium? This is the medium. I have brown, and okay, if it is brown, then the bird name will be song thrush. Okay. Look now, if here I will use the control if then else, okay? If the color is equal, if the color, okay, color here is equal to brown, so I will have a variable called name bird, okay, or bird name. I will set the bird name to what? To song thrush, okay? So this is the name of the bird, okay? Yes, I will set the bird name to what? To blackbird. Okay, so this is the for example the medium. Okay, I can what? I can test this one. Okay, so let's test. So what is the size of your bird? I will enter only 2. Why? Because only I will only 2. So in the 2, it will ask me for the color of my bird. Okay, so I need to brown. If I write brown here, brown. Okay, so I need here to say the here say bird name. Just a moment. Say here say bird name. Or I can here without any clarification, just okay. Okay, so it is song thrush. Okay, so do you see that? So I test my component, and my component is okay, good. Okay, is it clear? Is it clear? So this is my custom block for a medium bird. It is I can create the same one for the small bird and the big bird. Okay, and I can test all of them. Okay, in this part. Okay, so I can by the same way So this is my medium. For the small, okay, for the large, or for the big. Okay, are you with me? For the big, okay, it is the same thing. I will ask duplicate, okay. I will ask for the color. If the color is black and white, okay, black and white, then the bird name will be Magpie, okay. Else it will be the pigeon. So this is my bird part, okay. So let's now test my big bird, okay. So look here, look. What is the size of your bird? So it is big, so I need to enter 3, okay. So what is the color of your bird? It will be, it is black and white. It is a Magpie. It is, for example, black, okay. So it will be a pigeon, okay. If it is different from the black and the white, it will be a pigeon, okay. So my program works, okay, correctly, okay. Is it clear? And we can do the same thing for the small birds, okay. Duplicate. So I will ask for the color, okay. So this is for the small. If it is brown and red, then look, now we have 3 possibilities in the small, okay. So it can be brown. Okay, see, this is small. What is the color? If the color is brown, then set the bird name to what? If it is brown, it is sparrow. Okay. Else, I need here another if. Okay. So if it is not brown, if the color now is brown and red, if the color is brown and red, if the color is brown and red, so the bird name will be Robin. Yeah, good, هذا Robin. Okay. Else, if the color is blue and yellow, okay, so set the bird name to what? To blue tide, okay. Okay, are you with me? Okay, let's now test all of this, okay. So look now, we will start. What is the size of your bird? It is 1. So 1 for small. What is the color? For the small, you have 3 choices. If it is brown, so if it is brown, what is the answer? The correct answer should be the sparrow. Okay, it's good, sparrow. So I will ask again. What is the size of your bird? It is 2. Okay, for the 2, it is medium, so I need to be or brown, either brown or else. Okay, so if it is not brown, red for example, or black, okay, it will be blackbird. Okay, good. Okay, and now for the bigger, what is the color for the bigger? It can be, for example, the black and white, black and white, so should be magenta. Okay, so my whole program works correctly. Okay, all the tests that I have need. Okay, it is it very okay, very good. Okay, it works correctly. Okay, do you have any questions? Any question? No questions? Okay, thank you very much for your attendance, and I will take the attendance now. Okay, so thank you very much for your attendance.